Okay, we're gonna test critical points today to determine maxima and minima. Let me give you an idea of what this looks like. Okay, that is a quadratic, yeah? Critical point here. Can anybody think of a way to test to see if that's a max or min using a derivative?
Second derivative.
The slope is negative.
We'll get to the second derivative later.
Your point, the side of it. The slope is positive, the other point is negative.
Kind of like that.
So if the slope of the derivative or the value of the derivative changes from,
It was like those questions on the homework, giving us the graph.
if it goes positive to negative, it's a what? It's a max. So from left to right, we go positive to negative, it's a max. What happens if I go from negative to positive?
Let me guess. Hold on, let me guess.
You're too late. Nice try.
Nah, yes, well.
I do.
Hey, poor Dolly. Come again. I think you have to say something. Yes, I think.
Okay, so this is called the first derivative test. Okay, it's called the first derivative test. So again, the conditions there, f of x is differentiable. F of c is a critical point. Okay, if we go from positive to negative, it's a local max, and negative to positive, local min. That's guaranteed. It could be absolute, but we don't know it. Okay. Let me give you a couple examples, and then we'll be good. Okay, so let's analyze the critical points of x cubed minus 27x minus 20. Okay, go ahead and find the critical points. Right now. I'm going to come wander around. Practice using the derivative.
of a factor solved. John did the head from the original function.
Anybody having trouble? So critical points, positive or negative 3. Are there any places that that function is, the derivative does not exist? No, it's polynomial. Okay, so we're good on that definition. Okay. This is where the first derivative test comes into play. We know those are critical points. It's going to tell us what happens. So what you're going to do is pick a number and analyze the derivative at that for its sign. Okay, so if I pick -4, what's f prime at -4? The derivative now, we're analyzing the derivative. Last time we did the original function. Is it positive or negative? 4 squared, 16 times 3, 48. It's positive. Now pick 0 if you can. That is negative. And 4 is positive again. So what do we have here? Positive to negative? And negative to positive? Local min. You just pick one. You pick something on the left side and something on the right side. Okay, so does that make sense? Okay, so don't get confused with 4.2. In 4.2, we plugged into the original function to find min and max. This is another way to find a min and max using the derivative. Okay. We will actually be able to do it with the second derivative as well in the future, but that's for now, that's what it is.
So the graph kind of like,
So the graph looks like this. Positive slope, negative slope, positive slope. Okay, let's do one more and we'll be done. Let's try this one. The derivative is x squared minus 2x plus 1. Okay, so our critical point is 1. Can factor.
Oh, yeah. That's why. That's enough.
So the derivative at 0 is positive, right? Positive 1. And the derivative at 2 is positive as well. Can I say anything? Yeah. It is a critical point, but it's not a local max or min. Okay, it looks like this. Okay, so there is, it does hit, the slope of the tangent line hits 0 there, but it doesn't produce a local max or min. Okay, so be careful on some of those. You good?
Was this, sine related cosine?
Draw the graphs.
Okay. There it is.
Like 3 pi over 2 maybe. Okay, you have the homework already, right? Okay, you have the rest of the hour to work on it.